The universe does not do anything by halves. Out there, past the calm little corner we live in, are places so cold, so bright, so heavy and so violent that they push physics to its absolute limits, and every one of them is real. In the next few minutes we'll visit 7 of the most extreme places and objects we have ever found. From the coldest spot in existence to the emptiest hole in the cosmos. No exaggeration, no hype. The real universe is extreme enough on its own. Let's start with cold. You might assume the coldest place in the universe is somewhere in the empty void between galaxies. It is not. Empty space, warmed faintly by the afterglow of the Big Bang, sits at around -270 degrees Celsius. But there is one place colder. 5,000 light-years away, a dying star is blowing out gas so fast that the gas expands and chills itself, the same way a can of compressed air turns cold when you spray it. That place is the Boomerang Nebula, and it has dropped to around -272 degrees, just 1 degree above absolute zero. The coldest temperature physically allowed to exist. It is, remarkably, colder than the empty space around it, the only known place in the universe that is chilling itself below the background of creation. Now the opposite extreme, the brightest objects in existence. When a supermassive black hole at the center of a galaxy begins to feed, matter spirals in and heats to millions of degrees, blazing so fiercely that it outshines every star in that entire galaxy combined. We call these quasars, and the brightest of them shine with the light of trillions of suns. Some are so luminous that we can see them from more than 12 billion light-years away, which means the light hitting our telescopes tonight began its journey when the universe was young. The strangest part is what powers it, not the black hole itself, which gives off no light, but the doomed matter screaming as it falls in. The brightest thing in the cosmos is lit by the act of destruction. Our sun feels enormous. Over 1 million Earths would fit inside it. But on the scale of stars, it is small. The largest known stars are a class called hypergiants, and they are almost impossible to picture. Take one of the biggest, and if you placed it where our sun sits, its surface would swallow Mercury, Venus, Earth, Mars, and reach out past the orbit of Jupiter. A jet airliner flying non-stop would take thousands of years just to circle it once. These giants are so vast and so unstable that they are shedding themselves into space, burning through their fuel in only a few million years before they die in titanic explosions. They are the largest single things in the universe, and they live fast, and they do not live long. For the heaviest, most crushing matter in the universe, we go to what a giant star leaves behind when it dies. Collapse the core of a massive star and you get a neutron star, an object with more mass than our sun packed into a ball the size of a city, maybe 20 kilometers across. The density is almost beyond belief. A single teaspoon of neutron star material would weigh about 1 billion tons, as much as a mountain. Its gravity is so ferocious that the tallest peak on its surface, a bump held up against that crushing pull, might rise only a fraction of a millimeter. It is at once the heaviest and the smoothest object we know of, and some of them spin hundreds of times every second. Cosmic lighthouses left over from a star's violent death. Some of those dead stars hide an even more extreme secret. A rare type of neutron star, called a magnetar, carries the most powerful magnetic field in the known universe, trillions of times stronger than the Earth's. The numbers are almost cartoonish. If a magnetar sat where the moon is, it would wipe every credit card and hard drive on the planet clean. get within 1,000 kilometers, and its field would be so intense it would tear the atoms of your body apart, scrambling the very chemistry that holds you together, long before you ever arrived. Every so often, one of these objects releases a starquake, a sudden convulsion that unleashes more energy in 1/10 of a second than our sun puts out in 100,000 years. They are the strongest magnets nature has ever built. Here is an extreme you are living inside of right now. You feel perfectly still reading this. You are not. The Earth spins beneath you at over 1,000 kilometers an hour. It races around the Sun at 107,000. The Sun drags us around the galaxy at over 700,000 kilometers an hour. And the entire galaxy is falling through the universe, toward a mysterious mass we call the Great Attractor, at more than 2 million kilometers an hour. Stack all of that motion together and, at this exact moment, you are hurtling through space at a speed almost impossible to imagine, and you cannot feel a thing, because everything around you is moving with you. Stillness, it turns out, is the greatest illusion there is. We end with the loneliest extreme of all, the emptiest place in the universe. Galaxies are not scattered randomly. They hang together in great glowing webs and walls. But between those walls lie voids, and one of them is so vast it stops you cold. It is called the Botha's void, a nearly perfect sphere of nothing, around 330 million light-years across, with barely a handful of galaxies inside a region that should hold thousands. To grasp the loneliness of it, consider this. If our Milky Way had formed in the center of that void, we would not have discovered other galaxies existed until the 1960s. We would have believed our galaxy was the entire universe. Out there is a hole in creation so empty that a civilization inside it might never learn it was not alone. 7 extremes, and every one of them real, measured, and out there right now. That is the quiet thrill of the honest universe. It never needed the exaggeration, because the truth was always going to be stranger. One question, before you go. Which of these 7 would you actually want to see with your own eyes, if you could survive it? Tell me below. And if you want the honest version of the cosmos every week, subscribe and I'll see you in the next one.